The two Voyager space probes, which have been humanity's longest-running outposts, have gone to parts of space that earlier explorers would have never even dared to imagine. The unmanned spaceships left Earth more than 45 years ago, but their mission is still going on. On the other hand, the probes still send us useful information from interstellar space, reminding us once again of the mysteries of the universe that have yet to be solved. Do you want to learn about the amazing things Voyager saw at the edge of our solar system? Well, in this video, we'll talk about what kind of mysterious data Voyager sent to Earth after 45 years and what they mean. Keep watching till the end to know more. The space between the Sun and Voyager 1 is now 14.67 billion miles, which is virtually unfathomable. Only one other man-made object, its sister probe Voyager 2, has been able to journey as far into space in the history of space exploration. The spacecraft's initial mission objectives and compass are distinct realms of use, even if they are now communicating with us from a distance in interstellar space. In addition to studying the atmospheres, several fundamental properties of Jupiter, Saturn, Uranus, and Neptune have to be uncovered to greatly advance our understanding of these planets. The eye-opening pictures that surfaced were meant to provide scientists with a better understanding than ever before of our far-off planetary neighbors. It was time for Voyager 1, the first artificial object to go into interstellar space, to leave Earth in 1981. After the transit through Uranus and the flight to Neptune, Voyager 2's continued trip still included several intermediate stops. In addition, 9 previously undiscovered moons were discovered by Voyager 2, which is still the only spacecraft to have visited our solar system's 2 outermost planets in October 1989. Then, Voyager 2 continued the sister probe's cosmic path. Approximately 6 years after Voyager 1's arrival in interstellar space in 2012, its sibling followed suit. But what discoveries go along with this solar system-wide technological breakthrough? In essence, the evidence obtained thus far may be summed up by saying that interstellar space is weirder than previously believed. We must first examine how solar winds interact with the interstellar medium to properly categorize these fascinating discoveries. A network of dynamic magnetic field lines exists but is unseen. Electrically charged particles constantly escape along these channels, and the solar winds sweep over our whole home system, eventually coming into touch with the interstellar medium. The interstellar medium and the solar winds share the characteristic that they do not combine properly. Instead, the Sun's particle streams create an 11 billion mile long bubble-shaped bulge in the interstellar medium. We should be very appreciative that this bubble exists, as should the other heavenly bodies. In the end, it shields us from a significant portion of cosmic radiation. The data that Voyager 1 gathered at the heliopause in 2012 already showed how different this cosmic barrier was from what scientists had predicted. In actuality, the interstellar magnetic field is 2 to 3 times more powerful than previously thought. This leads to the conclusion that the pressure on the heliosphere from interstellar particles must likewise be 10 times greater. However, the measuring device for Voyager 1's plasma temperature has long since failed. Researchers paid Voyager 2's flyby even more attention. However, because of the diffuse and thin nature of the associated plasma, temperatures near the space probes are substantially lower. While Voyager 1 was getting close to the heliopause, Voyager 2 revealed proof that the plasma crosses from both sides of the various regions. On the other side, Voyager 2's passage revealed a very diverse and dynamic picture to unpack. It is not yet known when the next probes will follow in the footsteps of Voyager 1 and 2. Terrestrial researchers encountered a challenge last year that they were unable to solve. Unexpectedly, Voyager 1 started sending a tangle of telemetry data to Earth. It was immediately clear that there was a problem with the attitude and control alignment. The primary antenna of the spaceship must constantly face toward our planet, and this is the job of the Attitude Articulation and Control System, or AACS. This is the only way to guarantee effective communication over such great distances. The personnel on the ground rely on the radio connection to provide fresh commands to Voyager 1, while the probe utilizes the proper channel to communicate the data it has collected back to Earth. The spacecraft's ability to spew out telemetry data that was utterly meaningless constituted the largest enigma surrounding this technological issue at this point. However, except for that, it operated normally. As a result, everything continued to function as it had previously, including receiving orders from the ground and transferring data from the scientific equipment. The robust primary antenna was still pointed toward Earth, as shown by the fact that the signal intensity had not decreased. However, the data anomaly caused experts' heads to spin for a while. However, the AACS system attempted to relay the relevant data using an onboard computer that hasn't been operational in a while. So, the messed up signals slowly made their way to the stations on Earth as meaningless digital gibberish. The scientists now had a lead they could build on after locating the cause of the malfunction. The specialists sent the command to send the data back to the operational onboard computer in the future through the Deep Space Network's radio antennae. Fortunately, the scientists' efforts were successful, and they may now make use of accurate telemetry data once again. However, it is still a total mystery as to what led Voyager 1 to rely on the malfunctioning onboard computer in the first place. A malfunctioning command from another electrical component probably was what started the meltdown. Although it will certainly take some time for the specialists to scratch the surface of the error's origin, one encouraging piece of information is that both space probes have backup systems that kick in just in case there is a malfunction that cannot be remedied. Scientists don't know how long the two spacecraft will keep working, so they turned on extra flight control thrusters in 2017 to help keep attitude control thrusters from breaking down. In around 40,000 years, the spacecraft will have completed its scientific mission but will still be traveling. In 225 million years, at a distance of 1.6 light-years, Voyager 1 will pass the star Gliese 445, which is 17 light-years from Earth and at a period when mankind may have long since vanished. The distance the probe will have covered is the same as orbiting the center of the Milky Way. What do you think of the two Voyager probes' seemingly endless mission? Do you believe that the spacecraft's technical issues will worsen in the future? As usual, please share your opinions in the comments section below and don't forget to subscribe to the channel. We will see you at the next one. Thanks for watching.